Welcome to the second half of the webinar on climate change. This one we're going to look at what are humans doing to change Earth's climate system? How does the carbon cycle in and out of the Earth's atmosphere? And what are some examples of the impacts of climate change around the world? As we know, Earth's climate system is powered by sunlight, and it's the balance between the incoming and outgoing solar radiation that creates an equilibrium and a particular temperature at the Earth's surface. If we take a look at this animation, you can see the incoming sunlight as white dots, and as those white dots hit the surface, they heat it up, and that heated surface re-radiates energy, re-radiates heat back out to outer space. Now, the Earth's atmosphere has heat-trapping gases, most of which are related to carbon, or carbon compounds, that are transparent to incoming light, but are opaque to outgoing heat, and they actually will retain that heat at the Earth's surface, much like glass in a greenhouse, and that's why they're called greenhouse gases. As I add in more and more layers of glass in this particular model, you'll see that the temperature is rising because more and more heat is being retained at the Earth's surface. And this is what humans are doing by adding more and more carbon compounds, particularly CO2 or carbon dioxide, to the atmosphere. We're trapping more and more heat and upsetting the balance of the Earth's climate system. Carbon dioxide is the most important of the greenhouse gases. And carbon dioxide in the Earth's atmosphere is actually taken out of the atmosphere by plants for the most part, and sunk into the ground, sunk into the oceans through photosynthesis. Through photosynthesis, a plant basically takes in CO2, which is a molecule composed of one carbon and two oxygens. It breaks that in half, releases the oxygen, and takes the carbon, combines it with sunlight or energy and water, and creates what's referred to as a carbohydrate or a fuel. And if this carbon in its solid form gets buried in the Earth's crust, it can turn into a hydrocarbon once it becomes fossilized over many millions of years. And so carbon cycles in and out of the atmosphere, basically taken out of the atmosphere through photosynthesis in the creation of fuel. And then when animals consume that fuel, they re-release that carbon dioxide to the atmosphere. Again, plants that become fossilized in the Earth's crust, a lot of that, let's say, fuel will become concentrated in what's referred to as fossil fuels, such as coal, oil, and natural gas. And as humans burn those fossil fuels, we're releasing carbon dioxide into the atmosphere and increasing those heat-trapping gases that are upsetting the balance of the Earth's climate system. This animation here shows us the sources of CO2 from cities is the blue. So you can see, for example, Paris and London here, Eastern China, Japan, all of these places are giving off lots of CO2, which is blue. And also the burning of biomass in the forests, or also from cooking fires in Africa, in Southeast Asia, are also a source of CO2 in the atmosphere. As we add more and more of that CO2 into the atmosphere, the red line here is showing us over the last 1,000 years, the amount of CO2 has been rising dramatically. And along with that is a rise in the overall temperature, a dramatic rise in temperature over the last century. What does this mean? In terms of impacts, one of the most important things to realize is that the more energy in the atmosphere, the greater the ability of the atmosphere to carry water vapor. So this is grams of water vapor per cubic meter of air. The capacity of air to hold water goes up exponentially as the temperature rises, meaning that there's a lot more water in storms, a lot more potential for great rainfall, for torrential rains. There's also a lot more energy for the movement of the atmosphere to create stronger storms, stronger winds. You also have other impacts such as greater droughts, basically an upsetting of the Earth's atmosphere. The Earth's climate system is having very negative impacts